Welcome back. We're going to be looking at past questions related to electricity today. You can of course get the PDF version of these questions from the description below, so you could try solving them first and then coming back later to join us to see how correct what you have done is. Okay, so the first question is: the energy stored in a simple cell is A. Electrical, B. Nuclear, C. Thermal, D. Chemical. Okay, so the answer to this is chemical, which is D. Next one: an electric circuit consists of a resistor, a battery, and a key. If the voltage of the battery is increased, there will be an increase in the A. Current and resistance only. B. Current, resistance, and temperature. C. Current and temperature only. D. The resistance and temperature only. Okay, so if you even look at the Ohm's law, V is proportional to I. As V increases, I increases because it's directly proportional. So current increases with increase in voltage. Alright, so B, we have current, resistance, and temperature. Alright, so of course we just said current goes, resistance doesn't increase, it's definite. Alright, temperature increases with increase in voltage. Yes, temperature can increase. The temperature of the circuit would definitely increase with increase in current flow. Okay, so once you have increase in voltage, you're going to have increase in current, and what that's going to give you is increase in temperature. And that's why if you keep increasing the current, most likely components are going to burn out. And the reason why they're going to burn out is not necessarily because or directly because there's excess voltage on their terminals. No, it's because there's excess current flowing through them. That current flowing through them will generate too much heat energy and will damage components. So obviously current, temperature of the circuit is going to increase. So you see we have current increasing and we have temperature increasing. So our option for number 2 is C. Alright, so for number 3, what must be connected between the points P and Q to establish a certain steady current through the incomplete circuit diagram? A. Fuse, B. Ammeter, C. Cell, D. Voltmeter. Okay, so you can tell that what we need is a voltage source, because it's a voltage source that will determine that current flows through this circuit. Of course, we know that's what the voltage source does because it comes with a potential difference and mounts pressure on the circuit which you've made, okay, for the current to begin to flow. So first of all, we have fuse. Fuse obviously is not a voltage source and it cannot generate current for your circuit. B. Ammeter is not a voltage source. The fuse is used to protect your circuit from excess current flow. The ammeter is used to read off the rate of current flow. Okay, we have a cell. Yeah, a cell is a voltage source. All right, a voltmeter is used to read off voltage between two nodes. All right, so our answer is C, cell. Number 4, a potential difference of 12 volts is applied across the ends of a 6 ohm resistor for 10 minutes. Determine the quantity of heat generated. Okay, so we have, let's list out our parameters. We have voltage to be 12 volts, we have resistance to be 6 ohms, and we have time to be 10 minutes. So if we look at this carefully, we'll see that we can use the formula H equal to IVT. Okay, because you're actually looking for the heat this circuit generated. Okay, so you can see this is like an example that affirms what was said for, I think, question number 2. Okay, so if a potential difference of 12 volts applied across the ends of the circuit, all right, it's going to generate heat. That's why they're asking you to determine the quantity of heat generated. Okay, so we can use IVT to know what heat is going to be generated. So if we look at this, we have our temperature, correct, we have our voltage, but we don't have our current. Okay, so because of that, we're still going to move forward with another formula that is equivalent to this one. So I normally is V over R, that's I. Okay, so if you replace I with V over R here, you're going to get V squared over R and T. Okay, so putting in our values, we now have 12 squared over 6 times 10 minutes. Okay, we multiply by 60 to convert it to seconds, and we finally have 14,400 joules. So number 5, a device consumes 100 watt of power when connected to a 120 volt source. Calculate its resistance. Okay, we have power and we have voltage. The voltage across the circuit. We're asked to find the resistance of the circuit. Okay, it's more like we have a circuit, so we say this is the circuit, the end of the circuit. Okay, and we connect it to a 120 volt source, right? Okay, so these are 120 volt source. Now they're asking us to calculate the resistance. So what is the resistance? They're asking us to find the resistance of this circuit. Okay, so we have the voltage source and we have the circuit. So we already have our V. Then we have the power this circuit can consume. So how do we find our R? Okay, so obviously P is equal to IV. Okay, and like was said previously, I is V over R, so we're going to have V squared over R. So if we put in our parameters here, or first of all, we make R the subject of formula. If we do that, we're going to have R equal to V squared over P. Okay, then we bring in our values. Okay, put in our parameters here into the equation. We're going to have 120 squared over 100 watts because we've made R the subject of formula. So if we solve for that, we're going to have 144 ohms. Okay, so we move on to number 6. It says a lamp is rated to 40 volts, 60 watts. Okay, that's the rating of the lamp. Now determine the resistance of the lamp when it's lit. Okay, so what do? It's similar to the previous question. Power is 60 watts, voltage is 240 watts, and R is not known. So we're about to find R. So we do the same thing. So P is equal to V squared over R, and we know R is equal to V squared over P. If we make R subject of formula, so we have 240 squared all over 60 watts, and that gives us 960 ohms. Okay, so these are questions pulled out from the WAEC exams and JAMB exams. All right, we can see this is from 2022. So let's move on to the next. We have from WAEC 2014. A wire of length 100 centimeter has a resistance of 10 ohms. Its cross-section area is 0.005 centimeter squared. Determine its resistivity. Okay, so we talked about things that affect the resistance of objects or the resistance of conductors. Okay, so there we talked about length, area, density, and we related them all to resistivity. Okay, so we'll use that formula now here. We have length as 100 centimeter. We have our R resistance as 10 ohms. We have our area as 0.005 centimeter squared, and we have and we have to find our resistivity. So R is equal to resistivity LA, and we know that L stands for length, A stands for area, rho here stands for resistivity, R stands for resistance. Okay, so if we make resistivity the subject of formula, we have RA over L. We bring in our parameters. We have 10 ohms times 0.005 okay centimeter squared divided by length of 100 centimeters. So if we simplify that, what we're going to get is 5 times 10 raised to the power minus 4 ohm centimeter. Okay, that's the value of the resistivity of the wire. So number 8, we have a circuit is set up as shown in the diagram above. When the key is closed, the ammeter reading will be dash. All right, so we have to find what the ammeter reading will be. We know the ammeter reads the rate of current flow, so which means the ammeter reading is going to be in amps. It's going to be reading the current flowing through the circuit. So what do we do if we have a circuit like this and we want to find the current flowing through it? We can get the total resistance of this circuit. Okay, we can find its total resistance and divide this voltage by that resistance, and we'll get the current flowing through the circuit. Okay, and so that's what we're going to do right now. So of course, we need to resolve these resistors or find their effective resistance. And from the class and what we did in class, you can tell that this resistor is in series with this network of resistors, and these two resistors in this network are in parallel to themselves because, of course, they connect to themselves on both sides, while they connect with this one on just one end. The other end is connected to a battery. So this resistor and this network of resistors are in series, while these two are in parallel to themselves. So if we want to resolve this kind of network, we resolve the parallel first. Okay, so for resistors in parallel, we know what our formula is like. All right, there's a formula I gave that we can always just go straight to use. Okay, and that's the formula that goes R2 times R1 all over R1 plus R2. All right, so if we use that straight, we're going to still get the same answer, but then let's go with this one here for now. So we have 1 over R1 plus 1 over R2 to be equal to 1 over R equivalent R effective. So if we do this, we're going to have this to be 2 over 1. So it automatically means we'll have to find the inverse of both sides to have RAF equal to 1 over 2. So now we have to find the total resistance of the resistors in this circuit. So we add both resistances to get the resistance in series. So we have half plus 1 ohm. So this effective resistance here as half plus 1 ohm will give us 1.5 ohms. Okay, so we go ahead to find the current from the voltage we have and the resistance of the circuit. So we're going to have V over R, which is 3 all over 1.5, and that gives us 2 amps. Okay, so our answer is C. We have 2 amps for that question. So let's move on to number 9. Number 9 states a battery of EMF 24 volts, okay, is connected to 3 resistors PQR as illustrated in the diagram. Determine the voltage across the resistor Q. We're asked to find the voltage across Q. Okay, so you have to be able to look at this circuit and be able to analyze it properly. Okay, of course, we know the voltage across Q is same as the voltage across P. All right, and if you look at this carefully, we'll see that PQ network is in series with this resistor here, which is resistor R. Okay, so PQ is in series with R, while P and Q are in parallel with themselves. Of course, we know why by now. Okay, since we have this in parallel and we have them in series to this, the voltage across here, the voltage across resistor R and the voltage across the PQ network, okay, will sum up together to give us this voltage, 24 volts. Okay, when resistors are in series, there is going to be a voltage drop across all of them. If you sum up the voltages across each of them, the voltage drop across each of them is going to sum up to the voltage of your voltage source. So all we need to do here is to subtract 14 from 24 and we'll get the voltage across this network of resistor. And the voltage across this network is the same for both P and Q. The voltage across P is same with the voltage across Q. Sum of voltage or potential difference across resistors in series equals sources EMF. Okay, so therefore we have 24 minus 14, which gives us 10 volts. All right, so the 10 volts is equal to voltage across the PQ parallel network, and then we have automatically that the voltage across the resistor Q is 10 volts. So we'll move on to question number 10. It says in the circuit above, 3 resistors, 2 ohms, 4 ohms, and 12 ohms are connected in parallel, and a 12 volt battery is connected across the combination. The current flowing through the 12 ohm resistor is, okay, so this is from JAMB 2011. Okay, we have 3 resistors and they're asking for the current flowing through the 12 ohms. That's this one. Okay, so we know that the voltage across these resistors is obviously 12 volts. Okay, because they're in parallel, the same voltage goes across them. Having said that, to get the amount of current that flows through this, of course, is just to take the voltage across its terminal, across it, and divide it by the resistance, okay, to get the current flowing through it. So simply do 12 volts divided by 12 ohms. Of course, 12 volts across its ends divided by 12 ohms will give us 1 amp. So the answer is 1 amp. So we'll move on to number 11. Two resistors, 5 ohms and 10 ohms, are arranged first in series and later in parallel to a 24 volt source. The ratio of total power dissipated in the series and parallel arrangement respectively is, we have two resistors and they are arranged first in series and then in parallel. So we're asked to find the ratio of the total power dissipated for both when they were in series and then when they're in parallel. So the first thing we need to do is to find the effective resistance of this thing in series. Okay, so which is going to give us 15 ohms, okay, because we're summing 5 and 10 ohms together. We now get the power dissipated for the resistors in the series network. So and that will give us V squared over R. So if we bring in the values into that, we're going to have 24 squared over 15. So if we solve for that, we're going to have 38.4 watts. Okay, so we now go to solve for the resistors in parallel. All right, of course we know this formula, R1 R2 all over R2 plus R1 for resistors in parallel. We bring in our values, we simplify, we have 50 all over 15. So the effective resistance in parallel is 3.33 ohms. Okay, we now find the power dissipated in the parallel network. Okay, so V squared over R, that's 24 squared over 3.33 ohms, and we have our answer to be 172.97. We now try to get the ratio of the power dissipated for both of them. So if we divide 38.4, which we had here, by 172.97, obviously we're going to have 1:5 as our answer, because this 38.4 will go into this 172.97 5 times. Okay, so let's move on to number 12. From the diagram above, calculate the total current in the circuit. We know that this is the voltage source and we can see the direction of the flow of current. So current flows this way, okay, comes to this junction and splits in 3 ways. So current goes through this guy and goes through this guy and goes through this guy. So we're asked to find the total current flowing. The total current is I3, I2 and I1 summed up together. That's I3 plus I2 plus I1 will give us the total current. Okay, but then we don't have these values, so we can't just sum them. So to find the current flowing through the circuit, we'll find the effective resistance and divide the voltage by it. Okay, so the effective resistance of the resistors in parallel for 3 resistors in a network is this. Okay, of course, to get to this place, you have to do your 1 over RO equivalent equal to 1 over RO1 plus 1 over RO2 plus 1 over RO3. But if you simplify that equation, you will now be getting RO equivalent. Remember, not 1 over RO equivalent this time, but RO equivalent equal to RO1, RO2, RO3 divided by RO2, RO3 plus RO1, RO3 plus RO1, RO2. So if you put in our values here, we have 18 ohms times 12 times 6 ohms divided by 12 plus 6, 12 times 6 ohms plus 18 times 6 ohms plus 18 times 12 ohms. If we simplify, we have this. To further simplify, we have 1296 divided by 396 ohms. Okay, and then if we do simplify, we have 3.27 ohms. So now we have the resistance of the circuit and we have the voltage. We can now use Ohm's law to solve the problem. So current is V over R, which is 12 volts divided by 3.27 ohms, and that will give us 3.66 amps flowing through the circuit. So is that 3.66 amps that comes here and splits in 3 ways. Number 13, an electric device is rated 2000 watts, 250 volts. Calculate the maximum current it can take. Okay, if we have a device rated at this 2000 watts and 250 volts, of course we're dealing with power here, and we know that power is equal to I times V. So current times voltage, we have the voltage there already, so all we need to do is to find the current through that formula. All right, so we're going to have current to be P over V, so that will be 2000 watts divided by 250 volts, and that will give us 8 amps. So let's look at the last question, which is number 14. An electric appliance is rated 240 volts and 45 watts. Calculate the current drawn from the appliance. All right, so obviously it's exactly the same kind of question from 2018 jam. Okay, the previous one was 2013. So of course we just divide our power by the voltage. So 45 divided by 240 gives us 0.19 amps. Okay, thank you for joining in this class. I just hope there is clarity for the topic electricity, and that all issues you have with it, with what we've covered, is settled. Okay, we're going to still talk about electricity, but on a different level in the future class. Thank you for joining in.